So the second part of sig figs is going to be calculations with sig figs, and it's not too bad. I mean there's a few tricky things that can happen, but for the most part it's not bad. So let's just get to it. Let's say we have an example: 10.20 plus 1.3. All right. So what happens is for addition or subtraction, you use the least amount of decimal points. So for this one, 1.3 only has one decimal point to the there's only one number to the right of the decimal point. There's two numbers to the right of the decimal point here. So I guess okay, and a big thing when you're adding and subtracting, it's not dealing with the sig figs of the entire. It's not dealing with the sig figs of the entire number, because the sig figs for the entire number for this one is 4, and for this one it's 2. But it's not for adding and subtracting. It doesn't deal with it. It deals with the numbers to the right. So that means that for all addition and subtraction care about are that there's 2 numbers to the right of the decimal point and 1 number to the right of this decimal point. That means the final answer needs to have the least, meaning it needs to have only 1. So the answer will be 11.5. Yeah, so just to reiterate, like this one, in addition and subtraction, it only wants the least number of points after the decimal point. Okay, so another example. So you have 9.345 and 2.20. So this has 3 numbers to the right of the decimal point, and this has 2 numbers to the right of the decimal point. So once you subtract it, you'll get 7.145. But then you go back to your question, and it has 2 numbers to the right of the decimal point. That means this number needs to have 2 numbers to the right of the decimal point. So what we do is we round it. So 7.145, the 5 rounds the 4, so it becomes 7.15. And this has the same number. It has 2 numbers to the right of the decimal point. And I'll post a bunch of practice problems with that. And so for multiplication and division, so for this, it actually is the entire number. They want the sig figs of the entire number. Meaning, so this one has 2 sig figs for the entire thing and 2 sig figs for this entire thing. So your answer will be 10.64, but it only wants 2 sig figs. So this, if you round it, right, 10.6, it'll become 11. But 11's not actually like, it's 2 sig figs, but it's just better to write it in scientific notation. So it'll be 1.1 times 10. It's just overall it's just better to write it in scientific notation. And then division, and the same applies for division, but another multiplication problem. 3.64 times 2.4. So you look at this, and the entire thing is 3 sig figs, and this thing is 2 sig figs. So once you multiply it, you get 8.736. And what happens is you look for the least amount of sig figs, and that was 2 sig figs. So the answer will be 8.7, and there's no rounding. So once again, this is 3 sig figs, this is 2 sig figs. You choose the least amount of sig figs, which is 2, so this number becomes 8.7. So, I guess it's kind of tricky, but just do a bunch of practice, and it'll become really easy fast. So to go over it one more time, when you're adding and subtracting, you're dealing with the amount of numbers to the right of the decimal point. So the sig figs don't matter for addition and subtraction. It's the numbers to the right of the decimal point. But for multiplication and division, sig figs do matter. It's the sig fig of the entire thing. So that's sig figs part 2.